All right, we're looking at scatter plots. This is Notes 13.1. So kind of reviewing back through on your bell work and such, we're looking at different correlations and different R values, which was our correlation coefficient on that. Your correlation is just the direction that it's going. So on number 1, I had a negative correlation since my Y values were decreasing as X increases. On number 2, we have no correlation because there's nothing really going on. It looks like someone sneezed on your graph. And then for number 3, we have a positive correlation. When it comes to your correlation coefficient, you're looking at how close to a perfect line it is. Now you're going to have negatives and positives. So I already know that number 1 is going to have a negative, and I know that number 2 is going to be positive. And if there's no correlation, then 0 is right in the middle. So I already used that 0 that's up there. So when I'm looking, this one's on number 1, not as close to the line, it's more halfway, so we're going to do the 0.4. Whereas on 1, we got the positive, it's pretty close to that perfect line, so we're going to say it's closest to positive 1. So again, correlation looks at the direction and how close to a perfect line it is. So when we go to find that perfect line, we call it the line of best fit. So it estimates that equation that's going to fit your data the best. We use this on our graphing calculator with regression. So that's when on our calculator, we go to stat, we go to edit, we put in whatever values we need, and then we're going to stat calc. Now we've always used 4 and being able to use 4 to calculate it because we're doing linear. Well, now that we're in the quadratic unit, we're adding on, going to stat, calc, and 5. Now the trick is using diagnostics to know which one it is. So this is when we're looking at parts. So let's go ahead and let's make sure we have diagnostics turned on. So I know that I need to clear this. With diagnostics, we go, so these are those steps that they have written on here. We go to mode, we arrow up to stat diagnostics, highlight and select on, enter. So now it's on. So now when I go to find it, they're going to give me R and R squared. So when I go to stat, it's going to give me all that stuff, and it's going to either have, it's going to have R sometimes, it's going to have R squared as well, and we're going to start looking at both of those numbers. So that R squared is actually called the coefficient of determination. With that, the closer R squared is to 1, the better the line fits your data. So with this one, when we're starting to look at is it linear or is it quadratic, we're going to look at which one has a closer fit. So which one has an R squared value closer to 1. So here, just the things to look at. If I've got an X value of 0, what does that make? What intercept is that? It is my y-intercept. So I know that I'm going to have, even if it's not a perfect fit, I'm going to have a y-intercept that's going to be close to +4. It might not be exactly +4, depends if it's a perfect fit, but we're looking to know that I'm close there. So that'd be a good way to eliminate answer choices as we're going through. So we're using that part. We're going to use the linear or quadratic, trying to figure out which one works best. So if I go to stat, go on to edit, and I'm putting in my numbers. So -6, enter, -3, enter, 0, 3, 6, and then my y values 2, 3, 4, 5, 6. Okay, so I'm going to stat, go to calc, and I'm going to go check linear. 4 all the way down, calculate. So I've got an R value that's equal to 1, which means that's my correlation coefficient, and I have R squared that's equal to 1. So I know this guy's linear on it. So I know it's linear because I already have that perfect fit. So I know I have that on there, and then 0.3 repeating on that one. That, if I don't know what that is, I go out here and I say, okay, point bunch of 3s, math, enter, enter. and there's your 1/3. So then this becomes y equals 1/3 x plus 4. Now, you still want to check quadratic. So let's go look at what happens when I go to check quadratic. Stat, calc, 5 for quadratic. Go all the way down. Wait a second, this one has an r squared of 1 as well. What is going on? So I want you to write this right below it. So when I look at quadratic, it also had an r squared that's equal to 1. But I want you to see what else happened. If I go to write this equation, it would be y equals, my a value is 0, x squared, plus 1/3 x plus 4. What happens when you have 0 x squared? It's gone. It's zeroed out, which makes it to where it's not actually quadratic, it's linear. So sometimes it's going to look like both, but you got to pay attention to whether or not it's got that 0 as your a value. Okay, so let's try number 7. Go back to stat, edit, and I'm going to clear these out. So up there, clear, enter, go up, clear, enter, and re-enter mine. So -7, enter, -4, -2, 1, and then 30, -3, -15, and -18. Okay, so got all that. Stat, calc, 4 to check linear. Ooh, okay, so that's really, really close, so it might be. So I'm going to put my little r squared over here. So this one has r squared as 0.845. So we're going to take it to 3 points on it. So maybe it's kind of close, and it's got a pretty strong correlation to it, but I don't have the best fit on it. So let's go try the quadratic. Stat, calc, 5. All the way down. There it is. So it's going to be quadratic because there my r squared is equal to 1. So it's not as good as a fit. So then I want to write my equation on this. Ooh, this one's got another 0 in it. So I'm gonna sketch it down here. So we have a, which is 1 x squared, plus b, which is 0 x, plus c, which is -19. So I'm going to zero out what they've got there, and this just becomes x squared minus 19. Okay, our next part to it, we're going to start answering questions. So some of the things I want to be able to do is store that equation. The reason I want to take and store that equation is to be able to use it later. So be able to use that and not have to take and every single time go retype it in y equals, it's just there. So if we go back to stat, calc, 5, because we were in the quadratic, you arrow down to where you're at store regression equation. You select alpha, trace, select y1, click enter, and now you still have to go to calculate. So it's going to look like it's as normal. You're like, what did it do? Go to y equals. There's your equation. Now it's going to glitch out. Okay, fine. But we won't know 0.999999 is going to be our same thing. So it's going to use that same equation in there. So that allows us to go to our table and see all the stuff we need for it. Now the other thing is to be able to graph our scatter plot to see our scatter plot and see our line of best fit. So the first thing we're going to do is we're going to turn it on. So to turn on, you go to y equals, and up top you see where it says plot 1. So arrow up to where it says plot 1, click enter, so that now it's highlighted. Then I also want to use the stat one, and what I do by using zoom 9 is it shows me all of my points that I put into stat. So if we go zoom 9, there are all of my points and my perfect line that goes through every single one of them. So that's what we're going to use to answer questions that are like this. So let's try to look at it. A pumpkin is catapulted into the air. Then the table below shows the horizontal distances of the pumpkin traveled at different degrees. Write an equation that represents this situation. So if we're looking at an equation, I want regression. So I know that I have a table and I'm trying to get that equation. So I'm thinking stat. Now, here, we're going to go ahead and put in a stat, enter, and we're going to change these numbers. So up, clear, enter, over, up, clear, enter. So I got everything cleared out. And then I want to put each one in. 20, 30, 40, 50, 60, 70. And then 372, 462, 509, 501, and 537, and 322. Okay, so I go to stat calc, but I have to decide if it's going to be linear or quadratic. Well, we can check the r squared. So if I go to 4, enter, ooh, 0.05, ew, definitely not linear. So if I go back to stat calc 5, and I check that one, there we go. R squared is 0.999. So this one was stat calc 5 for quadratic because my R squared gave me a 0.999. You can't get much better than that when you're dealing with real data. So that's what I'm going to use. The other thing is I catapulted something into the air. When I launch something into the air, it creates a parabola. So I already knew it was quadratic. So I know that I'm going to have a quadratic equation when I know it's something launched in the air. So I want to take and write this equation. So I'd have y equals, and we're going to take this to the 100th. So negative 0.261, okay, so 26 x squared plus 22.59x and plus 23.03. Okay, now, if I want to make a prediction, I want this equation. And you know what I didn't do? I didn't store my equation. So I need to go back and I need to store that equation. So I'm going to go stat, calc 5. I'm going to go down to store equation, alpha, trace, have it on y equals for y1, enter, and there it is. So now when I go to y1, it's changed the equation that's in there. And I've got my plot turned on. So if I go to zoom 9, there are all of my points and my equation for my pumpkin, which means that I can find my maximum height by finding my vertex and using that. So that's when I got to go back to last unit and I got to think about finding my vertex. So that's second, trace. I want 4 for maximum. I'm kind of at the top, so I'm going to go left, enter, and then right, enter. And then I click enter one more time. So that gives me my full vertex. So my vertex is 43.2, and I got a y value of 511.08. But if it's talking maximum height, then I want the height of it. So I want its y value. So then my answer is only 511.08 feet. So just that y value to it. Okay, and then to the next video to get your domain, so to continue these notes.